I'm gonna start. I forgot to start recording, so I'm gonna start recording now. We're gonna start with question one of this, and the agenda is just look at tests. Look at like past tests, so that you guys will be ready for the test that's going to go on tomorrow. I'm pretty sure number one, if you guys don't want to solve this, I'm pretty sad. This should be a quick and easy problem, guys. Very quick and easy. Oh, I already know the answer to this. I don't even need it. Okay, sure. Okay, you can go on. It seems that people have the answer by now. Christian, that's incorrect. Yeah, Christian, that's incorrect. You don't need the ohm symbol. You don't need the ohm symbol. You can just type ohms. Like I don't know what everyone finds so difficult. You can just type ohms on there. Just type ohms. No, nothing I'm in real tests. You have access to the ohm symbol. Actually, most times I don't even remember using the ohm symbol. I always just write the manual word down because proctors, when you say ohms, the proctor should be able to understand that's the symbol. I mean, yeah. You guys gonna solve the question though? Because this question should be like a 5-second problem. I'm pretty sure you guys should know this. You just calculate the resistance between the two nodes. Really? How many people join every day? Okay. I'll need to wait for everyone's answer though. I'm gonna wait for everyone's answers. I'm not gonna say who's right or wrong anymore because I want to see everyone try. There's at least 10 people here. I don't want to ruin it for everyone else. Yeah, we can continue solving. I'm not telling you what's right or wrong. In fact, everyone can probably guess out of these 5, and then one of them will probably be right if someone tried. But actually, do your math for this one though, because if you can't solve this, then oh my god, your competition is kind of screwed. Did we explain right? Did James explain right hand laws? Did James explain left hand and right hand rule? Fleming's left hand rule or right hand rule? Okay, according to you guys, he okay, sure, the right, not the left. Yeah, the same thing. Well, there's different hand rules that you can use in different circumstances. Continue. I know you guys should be able to solve this. Continue. I mean, I'm pretty sure I want most people's answers before people just like tell the answer, because I don't want you guys to fall behind. Actually, man, Circuit Lab, there's so many people this year. Last year and the previous year before, no one did Circuit Lab. In fact, the year I started Circuit Lab, only 4 people were in it. Oh well. I guess there's now 10 plus. This year was also 4. Okay, I'm just gonna give you guys out the answer. So like you guys, okay, so you guys pretty much, I'm pretty sure everyone solved this. So basically, this is 10 ohms, so it's just 1 over 2 over 10, which is just 1 over 5, which is the reciprocal of 1 over 5, which is just 5. And then you just add that with 10 because they're in series, and you get 15 ohms. Does everyone get that? Does everyone understand that? Does everyone understand that? Everyone understand that? Okay, yeah, it was pretty simple. I'm pretty sure. Now solve this one. A 9-volt battery is connected to resistors R1 and R2 as shown in the diagram below. The resistor R1 has a value of R1 is equal to 12 ohms, and the resistor R2 has a value of R2 is equal to 24 ohms. What is the voltage across resistor R2? Oh, this is actually really easy, you guys. You guys should get this easy snap. No, I don't want to go to previous. Let me go on this one. I'm pretty sure I'm just gonna scroll down and then like cover up this part. Yeah, I gotta cover this up. Oops. Sorry guys. Windows is kind of dumb. Okay, perfect. Andrew, it's not E. And I'm not gonna tell anyone else. The first person answers, I'm just gonna say if they're right or wrong. That's the only thing I'm gonna say. You guys can manually solve this, or you guys can use your logistical skills for this. What are you guys doing? Wait. Have you guys tried manually solving this? Can you guys actually manually solve this? Because if you guys manually solve it, I'm pretty sure you guys will get a answer. I'm kind of worried for you guys with all your answers, because you guys are all wrong if that's your answer. What are you guys thinking? I don't know. Now I get it. Everyone's just copying someone else's answer. This is not good tactics. Copying someone else's answer isn't going to help you. Guys, why don't you guys do the math? I know it looks dumb, but do the math. If you do the math, you'll get the right answer immediately. There's a trick to this, but also doing the math, the manual way is also plausible. You can also use the manual way. I'm not telling you guys what the answer is. I'm just telling you guys it's not D. Guys, if you guys can't solve this, I'm quite worried for you. This is a series circuit, man. This isn't even when we get to the multi-parallel, so we don't even, this is like the basic circuits. I'm gonna wait for everyone to put down the answer. Are you guys serious? Are you guys really this serious? Anyone else got an answer? I'm not gonna tell what the right answer is. Telling the right answer is gonna ruin everything. It's a learning opportunity. Don't guess, actually solve this. Why don't you guys solve this? If you guys solve this, I'm pretty sure you guys can get the answer in 5 seconds. I can manually do this in my head and figure it out, guys. Read this question, just read it. A 9-volt battery is connected to resistors R1 and R2. Of course. Christian's on the right track, I'll tell you that. Because it's not EOA. Wait guys, what do you guys not get? This is supposed to be like a 1-second question in competition. Like this is supposed to be like 5 seconds. What do you guys not get? Okay, guys. I want you guys to actually know how to solve this. Do you guys actually not know how to solve this? This is machines. Do you guys actually not know how to solve this? You guys say C, but I'm not sure if you guys are just copying off Christian. Do you guys actually know? I'm pretty sure, be honest, if Christian said it and then you're just copying him, is that what you guys are going through? Tell me the steps of how you solve it, and then I might believe you. Tell me what equation you used and how you used it. Because it's a pretty bad idea to just copy someone. But I guess the easiest way to just do it is that you know that current is equal to. The easiest way is just current is equal to voltage over resistance. So we know the voltage over both resistors is equal to 9 volts. That's Kirchhoff's law. And then we also have the fact that you're supposed to add 24. This is supposed to be delta or whatever you like to use. You can use this. You can use delta. It doesn't really make a difference. But it's just 24 plus 12 because they're in series. So it's 9 over 36, which just gets 0.25. And you just and that's the current. And now we know the current, you just gotta multiply by the resistors. Yeah, I don't know what you guys took so long in this question for. This is the long way. The short way is that, okay, look, these are in series. So these resistors will actually be ratioed with each other. So this would actually get 6 volts and this would only get 3. This would only get 3 volts. You can look at the ratio of the resistors and then you can figure out value of the voltage value of the resistor so fast if you do it the way I do it. If you look at it, there's 24 and 12, so the ratio of how the voltage will be divided will be like 6 and 3. That's just the ratio. But you guys should have known how to do this though. Like, I don't know why you guys took so long for this. You guys guessed D because everyone said so. Okay, let's look at number 3. A scientist related changing magnetic fields to electric currents and invented the first electric motor and generator. Oh, wait a second. I don't think you guys know this though. Do you guys know? It is Faraday. Let me check. Let me check just quickly. I think it's Faraday. Yep. Yeah, you guys are right. It was Faraday. Christian, you're very knowledgeable. Maybe I don't even know what you guys look like. Maybe you guys can take a group photo on the last day, but that's it. Now this was a little tough one for number 4. I don't know if you guys can solve it or not. Oh, hi Christian. Oh well. A transformer is connected to a battery through a switch. The secondary circuit contains a light bulb, as shown in the diagram below. When will the lamp be lighted? Oh, I haven't taught you guys this actually. I think that's the. I know that's the. I'm pretty sure that's the answer. But just to confirm that I'm not being dumb, I'm gonna find the answer key to this. You guys already did one page. Look, you guys should use these test folders. Okay, look at these test folders. You've got bazillion test folders here. Okay, got all these test folders. You guys should use them to your advantage. Oh, and also at the very bottom, I think there's an answer sheet. JK. They didn't give us the answer key, really? Oh no, they did give the answer key. No, JK, they just gave us the answer sheet. Oh my god. 2020 div B then. Then the last one is div B folder. This is the only other one I know. Oh, we also have this test folder. You guys have so many you guys have so many. It's a great idea to go do practice tests. Yeah, Christian's right too. It's literally it's because transformers, all they're doing is just changing. They're usually used in AC current, but you can use them in DC current, and they just operate exactly like that. Yeah. Well, duh. No electronic works without current. No electronic works without current. You just need to understand that fact and overlook the transformer part. You just need to know. I'll explain transformers later. Maybe I'll explain transformers briefly. So transformers are basically related to how it's usually used in an AC circuit. What happens is that they change the number of coils is related to the current, which is related to the voltage. And how they do this is that the watts stays the same, but basically what there's a special wait, you researched this? Yeah, you must have researched this actually. Yeah, basically, it just decrease. Yeah, what happens is that it just decreases current and it increases voltage. That's basically what happens. It decreases current and increases the voltage so that the watts going through is the same. That's why when you look at transformers or any modern day electronic, it always says 60 watts because it takes in the AC power. And then it's always measured in watts though. That's correct. It's always low current, high voltage coming in, and then that's a step up transformer where it increases the voltage by decreasing the current, and that happens because you have more coils. Lol. Okay, sure. Lol. That's actually pretty funny, cartoon guide. But then that's basically what happens is that it just decreases and then it can also go the opposite way around, which it increases the current and decreases the voltage. That's a step down transformer. And all you need to do is that there's supposed to be a ratio, so that the ratio of the ratio of the coils is equal to the ratio of the voltages between the two sides of the transformer. But the current is inversely proportional, so the ratio, so that basically means, because remember I told you how the current increases when the voltage is decreased, it's inversely proportional to that ratio basically. Do you guys get that? The current is inversely proportional and the voltage is proportional. The watts, you just need to find voltage and current. There's no need, if you find voltage and current, there's no need, yeah. What? What do you mean by 1 over C? Well, here's the basis of okay. Okay, let me just tell you guys this then. The transformers, they basically have number of coils. So let's say N1 let's say there's 2 transformer coils. They usually look like this. And there's something right here. Usually that's how it looks like in a circuit. They may not have these 2 lines, but that's how they look. And let's say this is a step up transformer, so you want the step up transformer, so you want the voltage to go up. It's a step up. So then what will happen is that this would be N1 over N2. So basically how it works is that N1 over N2. I need to write this better. N1 over N2 is equal to V1 over V2. So literally the voltage would, so if this was say 8 coils, usually it's in the hundreds though, well maybe, it's in the tens, so usually 30 coils, and this is 40 coils, it would step up. So then this would be say this was 5 volts, you would transfer this to give me a sec, my math is so bad these days. 40 divided by 30 times, it's just 6.66. So then that means that this would be that means that V2 would be equal to 6.66. That's how it works. However, current is inversely proportional, because if you remember the formula W is equal to I times V, you need to understand that when V goes up, the watts always stays the same. That's how they're able to do this. This is supposed to be an AC current, alternating current. That's exactly what the name comes from too. The current changes. So then the current goes down with voltage, and the same thing happens the other way around. Voltage goes down, current goes up. And this is just watts, because watts always stays the same. So then in this case, it would be inversely, so then in this case in this case, and then in the case of we have it's supposed to be I2 over I1. I2 over I1. Do you guys get it? It's just inversely proportional. And then watts, you just multiply them together. Do you guys get that? Do you guys get that? Yeah. So yeah, sure. We'll have the recording. I'm sorry. Last week's recording didn't seem if you guys liked it too much because of the lagginess. I'm really sorry for that. I'm really sorry. But I think you guys understand this. That's just the basis of a transformer. You'll see one of these problems on every invitational test. This should be pretty easy once you know this formula, okay? Okay? Now let's move to the next question. Given 4 metal wires of equal diameter and length, rank them in order starting from best conductor. What do you guys think the answer is? Yeah. This is something you guys should know. I mean you guys should memorize. Copper is very conductive, but there's materials that are more conductive than that. I believe you guys can search up a conductive chart. I think you can search it up. I need to go. I need to have a movie teaching. No, I need. Just leave. How hard is it? Just. Sorry for that. So basically, you need to search up a chart of conductivity, and then you just need to charge of conductors, and I'm pretty sure silver is at the top. Silver is always at the top. Oh, I searched up. chart of conductors. So if you look at this, this is exactly what you're supposed to get. Silver, you're supposed to get this. Silver is the most. That's something you should understand. But copper's right in that. Gold, I don't know. Gold, I don't know why it's used. Okay, the reason why gold is used is because many of these materials, they're not pure. You need to understand this, that sure, gold is very good, but gold is good because many of these materials, they cannot be pure, but gold is a completely different story. Copper isn't really pure and silver isn't really pure, but then gold can be pure, and that's why in many of like electronics they use gold because it can be pure, and that's the main reason why. This is basically the chart, so then you would usually know it was D. Do you guys understand that? Okay, yeah, that's pretty simple actually. That's pretty simple. Memorize that chart or like have it in mind, okay? And then you need to, okay, now you guys need, I'm pretty sure you guys know the formula. I told you guys this. Why is W1 and W2 are made of material the same resistivity? W1 has a certain length and diameter. W2 is twice as long and has half the diameter. Which of the following is true? You guys know the formula, don't you guys? You guys sure it's A? You guys sure it's A? You guys 100% sure? Yeah, do your math. Actually do the math though. Like if you do the math, you figure it out pretty fast. You guys sure? What do you guys think is the what are you guys are you guys sure to keep your answer? You guys sure they have the same resistance? I'm telling you guys right now that they don't. There's no way they do. Like just think about this carefully. Wow. Oh, you need to look up the formula, huh? Oh, you guys should have this in your head. I have it in my own head. I would keep a lot of this inside my head because you need to memorize all this because it's just 10 times faster when you know it. You guys should memorize this stuff, but okay. What do you guys? Do you want me to tell the answer? Cause you guys would be surprised at the answer if I told you guys the answer though. If I told you guys the answer, you guys would be extremely surprised at what the answer is. Guys, there's a simple formula. Just replace numbers inside it and you'll figure this out in 1 second. I don't know what you guys don't... I don't know why you guys just don't do the real thing. You guys want to know the answer? Do the math, guys. Guys, do you guys know the formula? Tell me the formula. Someone in the chat tell the formula. If no one knows it, then I'll know. Yes, you're correct. You're 100% correct. Now all it comes down to is the ratio. Just solve the ratio. Like I don't know if you guys noticed or not, but you can just set the diameter and you can just set the area and length as the same thing. Wait, what? Exactly. You just need to know that. You just need to use. Okay, you need silence. You sure, Soham? Are you 100% sure, Soham? Are you sure, Soham? I can tell you. Some people are catching on now. I'm pretty sure if you guys did the math from the start, you guys will catch this on in 5 seconds. Oh, you guys starting to see the answer now? You guys starting to see the answer? Everyone's flexing. Everyone's starting to flex on each other, huh? You guys, tell me more answers and then I'll explain it. I know, but yeah, I need other people's answer. I don't want people to just, like... like I need people to, like, actually, like, do it? Like, I don't really want, like, people just spamming the answer and then everyone else copying off of that. No, does anyone else have an answer, though? My god. Fine, I'll just tell you guys the answer. I feel like everyone has started to get it. I believe it's E. So basically, that you can basically a great way that I like to call cheat. Where did my whiteboard go? I had a whiteboard open. Okay, I guess I closed it. Okay, so basically all you have to do is understand that it's just P over L over A, P L over A. Now you already know that P doesn't even matter in this case, so you're just comparing L over A's. So you can put anything as L over A. You could put area as 4 pi, and you could put area as like 16 pi, and you could put area as 16 pi, you can put L as like 1. It doesn't matter. You can say now in the other case, what happens is that W2 is twice as long, so you could just make this 2, and then you could just calculate that this is 4 pi, 8 pi, 4. Wait, what? 8, 16, 4, 8, then 4, then 2. Then this would be 4 pi. So this would just be carrying 1/16. Wait a sec. No, that wouldn't be 4 pi. I think I'm doing something wrong. This is supposed to be... one over... No? I'm right. It's supposed to be 2 over 4 pi. Because if it's 2 over 4 pi, this simplifies to 1 half. This simplifies to 1 half because you don't care about pi's. Pi's are the same in both, so it doesn't matter. And this has 1/16, and then you get in any case, this is, if you divide the two, 1 half over 1/16, that's 1/8. So you know that W1 is 1/8 of W2, or W2 is 8 times. You can plug in any number. You can just plug in any number. Like, it doesn't matter. In this case, just shoot, like, you could use it the long way and figure out the long math, but I just input random numbers and then see if it works. Now you guys should solve number 7. I'm pretty sure you guys memorized the formula. If you guys don't know the constant, I can explain that to you. Now you guys should solve this question. I know these questions are somewhat challenging, so I need you guys to understand that this is competition level also. This might take some time though. This is another ratios question. Are you right? Wait. I need more answers. I'm not gonna, not if the one person answers, I'm not gonna tell you guys the answer. That's something. Oh, you're the first one that answers. Oh, really? You want actually? Let me do some really quick math and let me see if you're right then. Okay. I get it. I'm pretty sure you're right, actually. Naren, I'm pretty sure you're right. I'm pretty sure you're right, Naren. I think everyone else knows the answer then, though. Yeah, I think, yeah, that is the right answer. It's another question based on ratios. In fact, I took this test ages ago, so I forgot everything on the test. Do you guys get it why though? Do you guys get why though? I'm just gonna explain this really quickly because I'm pretty sure everyone knows this formula. Q1 Q2 over D squared times K constant is equal to the force So we state that the force is equal to we can just state that we can just change everything to 1. We can ignore K because K is in both. We can ignore K because K is in both. That wouldn't make that would make a difference, but like you guys get the point. But like it's just if Q1 we could just set this as 1 over D squared as 1 squared. We can, and then that would just be equal to like that would just be that looks like a D actually. 1 times 1 over 1 squared, that'll just be get you 1. So force is equal to 1. But in the case you use you double it, you keep it the same, and then you half it to 0.5 squared according to what the direction says. Then you would get 2 over 0. Pardon my bad drawing skills. 2 over 0.25, which I believe everyone knows is 5. And that's no, not 5. I'm dumb. It's 8. Yeah, it's 8. I said the wrong thing, but you guys get it. Yeah, I'm telling you guys right now, plug 1 in for everything and you will be completely safe. Just plug in numbers. You can plug in any number you want and it works. We never get to nationals, Naren. In fact, we've never gotten to nationals in the history of Sierra Vista. We've only gotten to state. We're not that smart. We got JT that's too smart and we got Kramer that's too smart. Okay, now back to this question. I believe James probably taught you this. James taught you guys this, right? Okay. I'll give you a brief explanation. When capacitors are in parallel, you just have to add them up. It's the opposite of resistors. When capacitors are in parallel, you have to add them up. When capacitors are in series, you treat them like resistors. You treat them like resistors in parallel. Do you guys get that? You guys get my explanation? I know you guys trying to find the answer, but do you guys get my explanation? Capacitors. Okay, capacitors. Okay, who cares? Capacitors. Yeah, it's very simple. It's literally just the opposite of resistors. Think about it like that. You don't need too much of conc information besides that, because you should just know that anything in parallel to a capacitor has the exact same volts with the capacitor. That's all you need to know. So that basically that's you need to know. So now you need to look at the next question. AC voltage quantified, especially if it's oscillating in nature. What, do you guys know this question? This actually might be something you guys probably won't know though. Just use logical thinking. Just apply. Circuit is very connected to modern electronics. So if you look at modern electronics, you can probably figure out most of this if you guys wanted to. And don't copy other people, guys. I don't like people like that. Copying other people is a bad thing. You sure? You sure it's Tesla? Do you know what Teslas measure, Naren? I'll tell you what Teslas measure. If you're sure what Teslas measure, then they're not what you think they are. It's magnetic flux density. It's not. It's magnetic flux density. It applies to magnets. Actually, should I explain Teslas to you? I should explain Teslas to you then. Actually, I should explain magnetic flux density to you guys. If you look at this formula, you know that B I keep talking about? Okay, no. You know that B I keep talking about? Okay, you know the B force I keep talking about when it comes to magnetism? That's usually measured in Teslas. It's not the right answer. There's no difference. No, okay, yes, B means flux density. Tesla is magnetic flux density. But in the end, it doesn't matter because none of them are right, so I wouldn't even look at that. It's Hertz. It just Hertz. I'll tell you guys this. It's straight up Hertz. If you're on Dynamic Planet, you guys would know this. But Hertz basically just is derived from... I think you guys should know what... Actually, in 7th grade science, I'm pretty sure you guys will learn this. Hertz is just a measurement of how many waves pass through a certain point per second. And the reason why is because it's oscillating in nature, as it said. If you try to graph the voltage and current, it will just oscillate. Basically, it's just frequency. Yeah, James said that. It's frequency, basically. Magnetic flux density is basically that B force you guys see most of the time. I believe that's what magnetic force density... Yeah, magnetic force... Tesla is just a measurement for B. You know that B you keep seeing? I don't know why, but they put that for magnetic flux density. So that's basically just that B force you keep seeing in magnetism. So number 10 is a 13-volt battery is connected to resistors R1 and R2 in the diagram below. The resistor R1 has a value of R1 is equal to 18 ohms, and the resistor R2 has a value of 8 ohms. The rate of which electrical energy is expended in the circuit is... Okay, you guys should get this very fast. Very fast, very fast, very fast, very fast. You guys should actually get this extremely fast. Okay, I already got the answer. You guys sure? You guys sure? You guys sure? Wait, are you guys serious? That's not how you solve it. It's in watts. Do you know what watts mean? What is the formula for watts? I told you guys the formula for watts. What is the formula for watts? Energy. Yeah. What does, yeah. Then you use that. Yeah, exactly. Then what does IV mean? Type the, yeah. Yeah, this is why I wanted to go through competition questions, because I know just to clear up anything, because competitions where the real things are tested. Yeah. Yeah, you guys should now know this. Actually, I could do this without current. I can do this entire equation without current, because you can manipulate the formula W is equal to IV. And energy in a circuit always means watts, because watts is joules per second. Joules is what energy, the true measurement of energy is, but you can just, watts can also be expressed as energy in cases. Anyone else have the answer? Naren, you're right. Actually, yeah, you're right. Yeah, I don't want another answer because I know Naren's right. I'm pretty sure everyone knows why V equals to I. I'll just show a shortcut I took if you guys really want to use this. V is equal to I, W is, watts is equal to I times V. V times I, whatever you like to do it. So you can manipulate this. So W, you know how V is equal to I times R, right? Is equal to I times R. So then you can just make it as I times R times I, which is just I squared times R. You can manipulate like this. Or you can also manipulate this as I is also equivalent to voltage over resistance. is also equivalent to voltage over resistance. So I can just do W is equal, oops, voltage over resistance. So I can just do W is equal to V squared, V times V over V, which is just equal to V squared over R. That's how I did it. It works. It's a very fast formula you can use and takes like the shortcuts out of everything. You guys get it? Just manipulating formulas. Okay, yes, it's in power. Yes, you can also use, okay, watts also means power. You can also use that, but I use W. It's perfectly fine. I can use W, James. It's a measurement. I can use W if I wanted to. I can use P. Okay, you know what? The formal way to do this is to call it P for power, but I've never cared about that because I think it's easy for me to understand because watts is in W, so why not make the variable W? The reason why is because there's another thing. There's another thing that relates to W, but you can just change the power. But you guys get it? It's just manipulation. You guys can just manipulate the equation because when you can just manipulate vehicles, you can just manipulate equations these days. Okay, and that's it. And now we're gonna move on to the next question. Which digit does the color green on a resistor band denote? Actually, this is something you guys would 100% not know. You guys would probably not know this. Bruh, Naren, actually do your math though. Actually do it. I know the, okay. In your cheat sheet, you should always have the resistor color code. So this is something that you guys should probably know. I'll just tell you guys the answer straight up. I believe it's B. It's B basically, and that's it. I just checked out. Yeah, it's 5. It's just B. It literally is just B. You can memorize the colors if you want it, but I wouldn't suggest that because look, your binder you can just search for it and it's not that long. And that's going on top. The wire has a resistance of 45 ohms and potential difference of 9 volts is applied across it. What is the measurement of the current passing through the wire? You get a binder, Sahab. You get a complete binder. So in fact, you get a binder. I recommend a cheat sheet, not a binder. Well, you got a binder. In my opinion, should have like the first few pages should be about should be condensed information of what you don't know and what you need to grab at comp. The rest should be like general information, the entire information of circuit lab and past tests. The reason why is because no, the reason why is, yeah, Naren's right. His second answer's right. 9 over 45. The second answer's right. It's supposed to be 0.2 amps. Okay, what milli? Yeah, milliamps just means 10 to the power of negative 3. It just means 10 to the power of negative 3. Yeah. James, that's perfectly fine. They can put this into a calculator. It can bring a scientific calculator. Okay, I recommend this calculator. This calculator is like the key to competition. You can do anything with this calculator, okay? It's a scientific calculator, but you can pretty much do things that you can't do with most scientific calculators. Like you can just input equations into this and it'll solve the equation for you. I recommend this one. TI-36X Pro. Every past site only person recommended. No, it has functions you do not see on a regular scientific calculator. Not sponsored, yes, we're not sponsored, but I highly recommend this calculator. Like it's the pro to competition, and it might cost more than the others, but it has 10 times more functions and it's still scientific, but it's almost graphing except for the graphing function. Texas Instruments. It's TI-36X Pro. Always take this to comp. It can do a lot. You can even do a little bit of calculus on this, but it's just really good to use for physics events, okay? Now, the next thing is that the scientists that invented the first electric battery discovered that electric potential capacitor is directly proportional to electric charge. Who do you guys believe this is? Oh yeah, this can do quadratic formula. It can also do if you look at my polysolve, you can do quadratic formula, but you can also do the cube formula if you want to do. So you can just input the A, B, and C values. Yeah, got everything in there. And then, okay, so number 13, can you guys solve? I'm pretty sure you guys, if you guys think about this correctly, you guys would understand this pretty easily. Yeah, it's Coulomb. Which of the following is false about electric field lines? Okay, I already know what's wrong. I already know what's 100% wrong. Oh, those ones? Oh, whatever. Oh, those ones. Oh. Yeah. Well, you need to bring scientific calculators. You can only have scientific calculators. But, like, yeah. Scientific calculators is what you should have. And this one, I highly recommend. That last year, people, they're now like 10th graders, they recommended this calculator too. So you guys should take very good note of this calculator. It is the key to competition. It gives you an ace. It actually makes you better. It actually helps you a lot more than I realized. So basically, do you guys know how to do this? Do you guys know how to do this? Your basic knowledge of atoms should help you. Yeah, Naren's right, it's B. It doesn't show a proton would move in an electric field. Because electric field lines, they basically represent how like every electron or like proton and how the field basically works around them. It's not actually how a proton moves. It's basically just the own field of like a best way to put it would be like energy that comes it's basically just like it's just electric field lines basically. I think wait, I'm feeling really dumb. I feel really dumb. I can't really. Oh, I see, yeah. Wait a sec. Hey, actually, you guys should memorize this. You guys should understand this. Field lines never intersect each other. You guys need to know this. You guys need to understand this, okay? You guys need to understand this, okay? That's basically what this means, okay? Basically, this is exactly what you need to understand, and that's basically how it works. Wait a sec. Wait a sec. I'm wrong. It's not B. It's not B. It's not B. A proton can move in an electric field. JK, it's C. It's C. It's C. It's C. The reason why it's C is because the electric lines can cross. They can cross because you sure it's B? I'm pretty sure electric field lines are moving by positive. You sure it's B, Christian? Because I searched it. If you look this up, it says, as such, the lines are direct. If you look at this closely, it says, wait a sec. No, it's B. I'm dumb. It's just B. I'm being dumb here. I was right the first time. It's B. What is the electrical energy of a 1600-watt microwave that is used for 3 minutes? What do you guys think the answer is? I'm being dumb here. My original intuition was right. What is a 1600 microwave that is used for 3 minutes? It should be pretty easy. I'm telling you, watts equals to joules per second. So think about this carefully. Think about this very carefully, and I'll come back. 16. You guys sure? You guys sure? You know, look at the answer choices and think about it. Okay, I'll tell you guys this pretty simply. So basically, I don't know if you guys know this or not. Watts to watt hour, if you guys I believe you guys might have figured this out while you're seeing the definition. Watt hours means the number of watts per hour. That means all you have to do is that means that it literally just means multiply watts times hours. So now in this case it's 6 watts times hours. So now in this case it's just 1600 times 3 divided by 60. And that should get you one of the answer solutions. That's all it means. That's all it means. That's all it means. This is all it means. Think about it. Watt hours. It's just kilowatt hours, same thing. Watt hours. Kilo just means add the 1,000 times 10 to the power of 3. Yeah, that's pretty much it. I literally explained that. Okay, now this will be our last question before we leave today. In trying to wire a circuit, a resistor of 220 ohms is needed. However, all that available is a box of 100 ohm resistors. Which of the following arrangements come close to 220 ohms? Oh, this requires creativity. I think everyone should get this one. Oh, I already know how to do this. I know how to do this. I already have it in my head. You guys sure? You guys 100% sure? I'm not telling you guys the answer to this one. This one requires actual thinking, which is why I'm not going to tell you guys. You guys sure? Because I'm pretty sure you guys are not thinking correctly if that's actually, okay. You guys sure? You guys sure? Are you guys 100% sure? Because I'm gonna tell you guys that there is an answer that will get you exactly 220 ohms. There's an answer that will get you exactly there. It's wrong, Sahom. That's not C. I'm telling you guys straight up. It's not C. It looks right. It's not right. Looks right. Not right, though. Looks right. 225 isn't the closest. You can get on the dot 220. You can get on the dot 220. Yeah, Naren's right. It's just E. You just need 2 in parallel to get the 200 ohms, and then the remaining 20 ohms is just because you just need to understand that you're just finding the reciprocal. All the equations are just the reciprocal of adding up all the fractions, so it would just be the reciprocal of 1 divided by 100 times 5, which in this case it will just be, you're just trying to find what reaches to 1 over 20. So in this case, it's just 5 over 100 is equal to 1 over 20, which is why when you reciprocal that, you get 20 ohms. And that's where the remainder 20 ohms comes from. That's why you need 5 of those resistors in parallel and only 2 of them in series. Do you guys get it now? Yeah, I think you guys get it now. Do you guys get it? Okay, so I think class is done. And tomorrow we'll probably create a test for you guys. So see you guys. Bye. So, do you have a question? I can answer this. Oh no, this isn't the test. This isn't the test. You should go to, you know what, if you want to know how to make a binder, you should actually go to the, it may seem useless, you know, like that other class that teaches you how to like make a binder and cheat sheet, like that 3 o'clock one or something. That one I would recommend. Tanush knows what he's doing. To actually make a binder, what I would do for my binder is I would just make like a couple pages in the front that condense the information that you might need, like a resistor color code, some basic formulas, maybe a graph that you might need. That would be a first couple pages. The other like most of the other like rest of it would be comprised of 2 sections. Previous test you yourself took and you get to keep, so you put inside your binder so that you can reference what you didn't know and know at that time and like actually know the correct answers. Because if you do the questions, you'll know the answers. I mean, you'll know the answers. You'll know what question was that on. And then the other part would just be like all the information on Circulab. Find all the information on Circulab that you might ever need, because there's always going to be some short answer questions like that. Oh, really? You guys haven't, this is the easy part. You guys haven't seen the rest. You guys got electrolysis, you guys got okay, now you guys got to look at this. Electric diagrams, charts, this part. Okay, you know what? The hardest part is if I zoom out so I can like scroll easily. This one's actually pretty difficult. Looks easy until you realize I explained this. And then there's short answer questions. And then the hands-on portion is actually extremely difficult. I actually got the points, most of the points for this, but it's extremely difficult to do hands-on. And hands-on is worth a lot of points, but there's not usually a lot. And yeah. You guys don't get a grade. There's no grade. This doesn't affect solely grade. This is to help you guys learn, man. This is to help you learn. So the page can be, there's no limit to how many pages. It's just how thick the binder can be. I think the binder can be a couple inches. I forgot. 2 to 3 inches. I forgot. You can look at the rules to find how many inch binder, but you can put any amount of pages that you can fit in that number of inch binder. You can join the link. I think you can join the link. You can join the link. You can like, you know how you join this class? I believe there's a link for that. I'm not sure if they're still doing that class. If they don't do that class, then I might explain it tomorrow. But tomorrow we're probably going to take a testing class because that's a good idea. Whatever. See you guys. So bye, Soham.